Okay, so what I had you do first was label the X and Y axis. Now what I need you to do is I need you to start at the origin. You need 7 M&Ms, please. Why did I do that? Okay. You need 7 M&Ms. And starting at the origin on your X-axis to the right, I would like you to line up your M&Ms as close as possible, like so. You need 7 M&Ms to do this. Turn that off. Put it away, please. Can everybody line up their M&Ms? Are we good? All right, I want you to make a marking as close to the end of that M&M. And then you can move them kind of just to the middle center area. And does everybody have a marking right there? Do not eat your 7 M&Ms, but you can eat this other one, the other. If you have extra, you can eat the extra. Don't eat your 7 though. We need those. All right. And if you already ate them, well, get them from somebody else. You're going to need them. Okay. I need everybody to look carefully. What we are now going to do is we are going to take a compass. Not everybody has a compass. I don't have enough for everybody. You are going to take a compass and open it to the width so that you can make it the width from the origin to your marking. So from the origin to your marking. And make sure that's the width of your compass. I got to turn this sideways because I'm right-handed. From here, if y'all can please look up at me. It is easier to move your paper than it is to move the compass. It's also easier if you tilt the compass like I'm about to. So I'm going to take my compass. Do you see how it's like tilted and it's not straight up and down, but tilted? Make sure this is called a stylus. This is your pencil. Make sure your stylus is at the origin. And then move your paper, not your compass. My compass is not moving. Oh, wow, that was bad. There we go. My compass is not moving. Move your paper, not your compass. I messed that up just then because I was looking at the screen. There we go. And you're just going to go around. You can erase any extra mess ups you have. Go around. And your circle is probably going to be light. That's fine. Thank you, Jackie. And make your circle the width of your radius. If you are done, please look around you. Does anybody need a compass? Because we didn't have enough. Please share your compasses with other people. Don't eat your M&Ms yet. Does everybody in here have a circle drawn? Anybody need more time? Okay, look up at my board, please. What you're going to do now is where we were, go back where your x-axis was, where that marking was. This is going to be 0. What we are going to do now is we are going to line up our M&Ms to be the same length as the radii, like they were, the radius. And we are going to mark every time we go around the circle 1 radius. Make sure there are no gaps. Put them close together. Do you agree 7 M&Ms was the length of my radius? So now I can mark that. That is 1 radius for my circle, or around my circle. And then do it again. Now I've done 2 radii. And I want you to go all the way till you get back to your x-axis and 0. And once you're done, you can eat your M&Ms. And then I want you to attempt to answer number 6, A through D on your paper. Go. Answer question 6, A through D on your paper. Are we just missing Audrey? All right. Are we done? Everybody good? You might not know the answers, but you looked over it? Okay. Let's go debrief all of this together. So, we did 1 through 5 together. What we are going to do now is answer the questions on number 6. It says, using the 7 pieces, continue marking off the radius length, but do not go past 180. We went past 180. That's okay. So, how many complete radius lengths fit into the semicircle to 180? 3. Do y'all agree? Did everybody get at least 3 whole radii through the semicircle, through 180 degrees? So can y'all all label this as 180 degrees? How many pieces of candy are needed now to complete this 180 degrees? Because it doesn't go all the way. How many pieces of candy can I probably fit right here? Probably 1. Is that the case for you?
Yeah.
Give or take a little, like 1? If you're, it might be a little bit bigger, a little bit smaller, that's okay. But give or take. So, 1 piece would need to complete this semicircle. How many pieces of candy would that be total on? How'd you get 22? Because there are 7 M&Ms times 3 radiuses, right? Plus the 1 little straggler we got, that's 22. So there are 22 total pieces of candy in the semicircle. So how do I write that as a mixed number? 3 whole radii and 1 out of, nope, how many candies are there? 7. That's our mixed number. How could I turn that into an improper fraction? 22 over 7. 22 total candies out of the 7. Does that make sense? What is that as a decimal? Oh. It is 3.14. And how can I represent that as a symbol? Ladies and gentlemen, this is where pi comes from. The whole point of pi and where it comes from is a circle. Open up your notes. We're not done. What about a full circle? How many radius lengths fit into the full circle? 6. And how many pieces of candy do you think I would need to complete this? Probably I could fit like 2, 1.5-ish. We're going to round it up to 2 to be accurate. So how many pieces of candy would that be? 6 times 7 is, plus my little stragglers is, we would need 44 total pieces of candy. How do I write that as a mixed number? 6 2/7. And how would I write that as an improper fraction? 44/7. So what is 44 divided by 7? And I know it rounds up, but I'm just going to keep it 6.28, which can be represented as what? 2 pi. So, what questions do I have so far? We're not done blowing your mind yet. If you come down here, this is our lovely, lovely, adored unit circle. And this is what your first quiz is going to be. Okay? We always are going to have 0 degrees right here. Around here, a semicircle is 180 degrees. And a soul circle is, so wherever 0 is, there is also 360. I think the AC broke again. Yeah. So whenever the fire alarm goes off, the AC turns off because they don't want fire to spread, air blowing, right? Like, makes sense. Every time the fire alarm goes off, this happens. But it feels like it did not turn on. No, it did. Like, it during 5th period, it cooled down. Cooled down. We weren't like dying during 5th period. Okay. 0 degrees is 0 radians. How many radians is 180 degrees? Pi radians. How many radians is 360 degrees? What did we just learn? 2 pi radians. And you don't actually have to write out radians. If you don't label it, it's given radians. Okay? So, how many radians are in one circle? If you tell me 2, this right here is 2 radians. How many radians are in one circle? Don't give me a decimal. 2 pi. 2 pi radians are in, don't forget that pi, that's a big thing. 2 pi radians are in a circle. Use a calculator to calculate. I'm going to do that for you. How many degrees are in 1 radian? Well, how many degrees are in a circle? How many radians are in a circle? So what is 360 divided by 2 pi? Because I don't have a pi symbol, I'm going to do the 6.28. How many degrees are in 1 radian? 57.3 degrees. And if you were to get your protractor and you were to measure, let's connect, I'm going to connect this to the 1, my origin to my 1 radian, just so I can see it. All those numbers are backwards. And you were to measure the number of degrees on this right here, it's not going to be super accurate because there are different variables you could have messed up. But about how many degrees does this protractor measure? Don't y'all agree it's between 50 and 60 right there? Don't you agree it's after 55? So 1 radian, this just proves it, is 57.3 degrees. You don't have to memorize that or anything. I just want you to know. I need you to see the difference between 1 radian. Where's 1 degree at? Isn't it right by 0 degrees? 1 degree is like over here. Here's 1 degree. You see how big that is? Here's 1 radian. And here is 1 pi radians. So when I ask you, hey, how many radians is a semicircle? Don't tell me 1. What are you going to tell me? Pi. You can say 1 pi or pi. Same thing. Okay? What if I want to know about the distance around a circle? What is that called? Circumference. Can everybody write circumference in that next blank? Circumference. Does anybody remember the formula for circumference? Where does the formula for circumference come from? How many radiuses are in a circle? 2 pi times your radius. That's how they found it. So that is where your whole life y'all been doing, not your whole life, but like Probably since 5th grade, y'all been doing these formulas, right? And you were just giving them and you didn't know what they mean. Now you know what they mean. So how does this compare to what we just discovered? An entire circle is how many radians? 2 pi. All right. So I have 5 minutes. I have 5 minutes. We're going to go over this. We're not finishing the next page. But what we are going to do now is, what I want you to do is I want you to, on this little circle right here, create a center somewhere, preferably in the middle. And I want you to guesstimate, actually, let's not guess, let's guesstimate where 90 degree is so that it's a vertical line. Cut your pie into 4 pieces. These 4 pieces are called the quadrantals. What do I start at? 0. What is this going to be? 90 degrees. Do y'all agree that's a 90 degree angle right there? And what's this going to be? 180. And down here, 270. You just add 90 each time. And then don't forget, with 0, always 360. That's the one people forget, because they do it all, but they forget to add 3. I forget to add 360 all the time. Y'all are going to have to remind me to do that. These are called your quadrantals. What are they called? Everybody say quadrantals. The quadrantals. They're like your 4 corners of the unit circle. All right? Now, I'm going to cut this in 2 more pieces. So put your protractor. I want you to kind of estimate, where is 30 degrees? Mark it. Where is 60 degrees? 30 degrees, mark it, 60 degrees. And we're going in increments of 30. What would come after 90? Mark where you estimate where 120 degrees is. And then 150. It doesn't have to be a perfect, like, we'll do that tomorrow. This is just an estimate. 31. And then I want you to go through the origin and make this into a pie cut in pieces. And then keep adding 30. What's 180 plus 30? Plus 30, plus 30, plus 30, plus 30. Are we good? Okay, I'm going to quickly fill out this chart and then we'll be done. Be careful. These say semicircle. How many pieces are in a semicircle here? 6. Do y'all agree? 30 degrees is how much of the semicircle? 1/6. Everybody write 1/6. 60 degrees is how much of the semicircle? 2/6. And although y'all are right, we're never going to actually write 2/6. What do I want you to write? 1/3. 90 is 3/6, which is 1/2 of the semicircle. Am I going too fast? 120 is how many slices? 4/6 or 2/3. 150 is, or there's nothing, it's 5/6. And then 180 is how many slices of the pie? 6/6, which is a whole semicircle. Do y'all agree with that? Okay. What is 210? 7/6. I want you to finish this chart by tomorrow, y'all can start packing up. The bell's going to ring in a minute. Just before you get into class, finish the top. Don't worry about the bottom. We'll finish that tomorrow. I know I went fast. Thank y'all very much. And if you're not going to eat your M&Ms, you can throw them away or give them away.